in this investigation, so 2 to the 8th was 256, okay, and then 16, and then 4, and then 2. And so most of you discovered that the pattern here was taking the square root each time to get down. So if the powers were halved, the numbers were square rooted. And since the square root of 2 is not a whole number, we just write this one as square root 2. 5 to the 1/2 would be square root 5. 9 to the 1/2 would be square root 9. 10 to the 1/2 is square root of 10. But I just want you to see that. So you get that x to the 1/2 is the same as what? Square root of x. Okay. So if we did 2 to the 1/2, it was square root 2. 5 to the 1/2 is square root 5. 9 to the 1/2 is square root 9, etc. Now at the bottom, it asks you to consider then, if x to the 1/2 is the square root of x, what is x to the 1/3 power? Cube root. Good. Cube root of x. So square root means it's an index of 2. It's the square root, meaning second root. 1/3 power is the cube root of x. How about x to the 1/5 power? The fifth root of x. So when they ask you at the bottom, what is 8 to the 1/3 power? No. Huh? 8 to the 1/3 power is the same as saying the cube root of 8. And when you do the cube root of 8, you're asking yourself, what do you cube to get 8? 2. Good. That's the cube root. And if you're doing that on your calculator, this is how you will need to type it in if you have an old operating system. 8 caret, and if the caret actually shows up on your calculator screen, you have to put parentheses 1/3. I don't have to do that because I don't have the caret. It's a newer operating system, but if you get the caret, you have to put 1/3 in parentheses, and it will show you that that's a 2. Yes?
I just have to put it in.
Right, so you must have a newer operating system. So, but if, for some people, theirs shows up like this.
Oh.
And then they have to type in 1/3, or else it will just take 8 to the 1st power and then divide that answer by 3, which is not the same thing. So the conclusion that I wanted you guys to come up with is that a to a 1 over n power is the same as the nth root of a. So that is the generalization of what you guys discovered during your investigation. So this is where you want to add this to your notes. Okay, so we are at 8.5a, and we're going to talk about the relationship fractional exponents, this is the exponent, this is fraction, have with roots. So the square root is x to the 1/8, or sorry, 1/2. Cube root, x to the 1/3. So whatever you are dividing by is the root. And so when I take numbers to fractional powers, in my mind, I always think of them as a root. I don't think of them as that power because my brain thinks better in terms of square roots than it does in terms of fractional exponents. So if you have a number to a power and it doesn't have a numerator of 1, this is the rule. And let me just show you what that would look like. If I took 4 to the 3/2 power, okay, you can do that as well. The way I would write that is my root is 2, because 2 is in the denominator. So this is the square root of 4 But do you see how it's to the third power? So it's a square root of 4 to the third power. Or if you had, let's say, let me not do 4, 16 to the 3/4 power. Whatever is in the bottom is the root. So it's the 4th root of 16, and that's to the third power. So whatever is in the numerator stays a power. Whatever is in the denominator is the root. So if I were to figure these out, first I would take the square root of 4, because taking the square root and the roots always make numbers smaller. So it's better to make numbers smaller before they become bigger, because, I don't know, it's just easier to do it in your head. So the square root of 4 is 2. 2 to the third power is 8. So 4 to the 3/2 power is 8. Any questions on that? What's the 4th root of 16? What do you take to the 4th power to get 16? It is 2. This is 2 to the third power, which also happens to be 8. They won't all be 8. Yes? So, let me show you what the problems look like. First, we're just going to get some practice moving from radical notation to exponent notation. So how could I rewrite 3/4? Sorry, that was 34. How do I rewrite 34 as 34 to a power instead of it with a radical? Denise?
Question.
Yep.
When I put into my calculator, it come out like I'm trying to switch in the different systems.
So,
And the 4.
so which one did you try?
I put the 4 outside the radical and I put the parentheses around the 4 outside the radical.
So 4 to the 3/2 power.
Yep.
When you do that, yeah. You need the parentheses then, Denise?
Yeah.
DJ?
Okay.
All right, what is it? 34 to the what?
1/2.
1/2. So what you want to ask yourself is, what's the power of 34? Well, 34 is just to the first power. So this is 34 to the first, so that 1 goes in the numerator. Then you ask, what root is being taken? Well, it's the square root. So the 2 goes in the denominator, because it's square root. So that is 34 to the 1/2 power. This is Bx to Isabel what power? 1/4. Good. 4th root is the same as the 1/4 power. And how about C? How would I rewrite that? Charlize? 4/3. Good. So the power goes on top, the root goes on bottom. And the way I remember it is roots make numbers smaller, just like dividing makes numbers smaller. So the root, which is the 3rd root, makes the number smaller, and also dividing by the 3 makes it smaller. Powers make most numbers bigger, so that goes on the top. Questions? So that's switching forms. And we can also switch from fractions as exponents to radicals. So how could I rewrite 25 to the 1/2 power? Ashley? Radical 25. And Ashley, can you go ahead and evaluate that for me? So for me, it's much easier to evaluate when it's in radical form, because I'm asking what number do I square to get 25, and then I get 5. How about rewriting? Go ahead, DJ.
It's cube root of 125, which is 5.
Yeah, because 5 cubed is 125. Elisa? Sure. Is that what you were volunteering for? Okay, go for it. Cube root. Square. Do you want to evaluate as well? No? We'd like to evaluate that. Gotta think of what's the cube root of 27? And then square. Okay. So the cube root of 27 is 3.
And the square root is 9.
Beautiful. All right. But notice, if I could have also written C like this, because these are both equivalent, I could have written the cube root of 27 squared. These are the same thing. The two can go inside the radical or on the outside. But what's 27 squared? You know. Okay, well, we'll get that. 27 squared, I have no idea what that is. But I do know the cube root of 27, and I know how to square 3. So I always tend to write the power on the outside because it makes the number smaller first, and then it makes it bigger. So it's easier to do in your head. But it is equivalent. Yes?
So what is this? The cube root and then the 13 just cancel out.
Do cube roots and cubes cancel each other out? Do cube roots and cubes cancel each other out?
No, yes.
Yes.
Yeah.
Yeah, because squares and square roots cancel each other out, so cubes and cube roots cancel each other out. Another one thing? Oh my Lord. We're almost done. Yes.
So if you do 27 times 27, you get 729. Where's the cube root?
Where is the cube root button? That is a great question. So when you go to your calculator, guys, go ahead and find the math key. So the cube root is number 4. So the cube root of, what is 27? Well, I could just write in 27 squared. I don't even have to do it. You can see that it's 9. But if you, let's say, want to do the 4th root, you would type in 4 math and then go to number 5. 5 allows you to do any root. Do you see how that's an X? So you can do any root there. So if I type in the 4, it'll do the 4th root. If I type in 10, it'll do the 10th root.
I got 4 cubes.
So the 4th root of 16. So that's how you do it. But DJ, 27 squared, right? Well, let me show you something cool. 27 squared, 27 squared. I'm going to write that in parentheses. Oh, that's really tiny. Okay. I could take that to the 1/3 power. Isn't taking something to the 1/3 power the same as taking the cube root of it? So you should get the same thing. Oh, yeah. It's messed up because my 27 cubed is squared is weird. Let me redo it. To the 1/3 power. And again, I don't need parentheses because I have this operating system which writes it as a power right away. But if your operating system just writes it all in a line, then you need the square, the parentheses. So That is the same as taking the cube root. So you don't have to use the math. You can just use the fractional exponent. So those are fun. If we wanted to write these in the alternate form, this would be x to what power? Maggie?
Is it 1/5?
What sort of root is it? It's what type of root? Is it a third root or fourth root?
Square.
So it's x to what power? And because of the 5, it's going to be 5/2.
Oh.
Because the power goes on top, the root goes on bottom. This one's interesting. This is 1 over m to what power? Amelia? 3/5. Good. The 3 goes on top, the 5 goes on bottom. Can someone help me rewrite this so it's no longer a fraction? Denise?
But you have to flip it.
Yeah, so it'd be m to the what power?
Backwards.
-3/5.
Oh, why?
Because,
Oh, because it was positive under 9.
yeah, it was positive under, so if we bring it on top, it's negative.
Would you rather have us write it like that?
Yeah,
What? So the power becomes negative, not the m.
correct. The m stays m. How about 7 to the 2/5 power? How would I write this with a radical? Brennan?
3 squared times 7 inside, and then 7 squared, and then
What goes in here? So the 5th root of x to the 7th. Good job. And this would be the 4th root of x cubed. But since it is negative, it's 1 over that. All right. Sorry, it is time to go.